Hello, and welcome to PMP certification course offered by Simplilearn. In this lesson, we will focus on project quality management. Let us begin with the objectives of this lesson. After completing this lesson, you will be able to define quality and quality management, differentiate between quality planning, quality assurance, and quality control, explain cost of quality and its categories, describe the project quality management processes, explain the 7 basic tools of quality, explain Six Sigma. In the next screen, let us take a quick look at the project management process map. The project manager is responsible for quality in a project. However, it is also the responsibility of each and every one in the project to ensure that whatever they do meets project quality expectations. Quality is defined as the degree to which a set of inherent characteristics fulfills requirements. A project is said to meet quality expectations when all the project requirements agreed in the beginning of the project are met and the resulting product is usable. Usable means that the intended users can use the product without any problem. In the next screen, let us look at some quality-related terms. It is important to discuss a few terms to understand the concept of quality better. Customer satisfaction is defined as conformance to requirements and fitness for use. It is important to understand the subtle distinction between quality and grade. Grade is a classification based on technical characteristics. Low quality is always a problem, but low grade may not be a problem. Rather, it would be a matter of choice. Similarly, it is important to understand the distinction between precision and accuracy. Precision is the granularity of measurement. That is, how fine-grained can you measure the outcome. Accuracy is how correct you are. That is, how close you are to the desired value. In the next screen, let us understand the concept of optimal level of quality. Quality comes at a cost. More effort put in quality will give better results. However, you cannot keep on investing on increasing the quality, as there is no limit to how much a product can be improved. Investment in quality is determined by knowing the optimal level of quality. Optimal level of quality, as shown in the diagram, is said to be achieved at the point where the incremental revenue from improvement equals the incremental cost to secure it. Suppose you are the manufacturer of toys, but the toys are below quality and the sales are low. To improve the quality, you invest in identifying the demands of children, sharing few samples, and recording their feedbacks. Once all these are captured and implemented in the products, you lure the parents to buy them. As the investment is increased to manufacture good quality toys, the cost will therefore increase, and it might become prohibitive for parents to buy. Optimal level of quality is reached at a point where you get maximum number of buyers for the toys manufactured. Now that we are clear on the concept of quality, in the next screen, let us discuss quality management. Quality management involves performing activities like creating standard policies and procedures and ensuring that those standard procedures are being followed properly in the project. It aims to ensure that project meets all the initial agreed requirements without any deviation and that the specified approach to quality is implemented on the project. 3 broad activities are done as part of quality management. They are quality planning, quality assurance, and quality control. Quality planning is the first step when quality-related activities of the project are planned. Quality assurance is the next stage of implementing those quality plans, and quality control is the last stage when periodic checks are done to see if project quality is improving. In the next screen, let us look into the differences between the 3 aspects of quality management. It is important to understand the different kinds of activities that come under quality planning, quality assurance, and quality control. Once the quality planning is done, the quality management plan is ready. This quality management plan has standards, templates, policies, and procedures to be followed in the project. It contains information on the level of quality being aimed and the plan to achieve that level. It is the aim of quality assurance activities to ensure that the activities planned under quality planning phase gets executed for the project. It is the task of quality assurance to determine if the project is complying with the organizational as well as project policies and procedures. This is ensured by conducting regular process audits to identify deviation from what is planned in the quality management plan. These audits are generally done by quality department of the organizations. Quality assurance focuses on the process, not on specific products. The role of quality control is to measure specific project data or results against standards to inspect and verify the project's product, defect repair, and measure whether quality indicators are improving. Quality control is about the product and data. For example, it was planned as part of quality management that project would get completed plus or minus 10% within the cost budget. 3 months back, when the measurement was done, project was over budget by 20%. When the measurement was done a day before, it was only 15% over budget. Therefore, the project has showed an improvement of 5% in the last 3 months, and it is quite likely that over the next 3 months, project may get within the planned limit of 10%. Instead of showing improvement, if the data shows cost increase, then corrective and preventative actions are required to get the project within the 10% limit. This is quality control. In the next screen, let us discuss a few quality management concepts. Let us look at some terms that are commonly used in quality management parlance. Total Quality Management, or TQM, is a quality management philosophy that involves holistic thinking about meeting the objectives of an organization. It places the responsibility of quality squarely on the management. Kaizen is a Japanese term that stands for change for better. Kaizen philosophy is one that should always be looking for small and continuous improvements in the process. Deeming cycle, or PDCA cycle, that is, plan, do, check, act, is a process control and improvement approach propagated by the famous quality guru Edward Deming. It means you plan for something, execute it, check the output, and based on the lessons you act to bring the deviations under control. Kanban is a pull-based management system that originated in Japan, based on just-in-time (JIT) inventory management. The idea behind Kanban is to minimize the work in progress and achieve a smooth flow in the process from start to finish, because building up inventory only to paper over the imperfections in the system tends to hide the problems. In the next screen, let us focus on cost of quality. Cost of quality is the cost that needs to be incurred to make a quality product. The sum of all the costs incurred is ensuring that project conforms to requirement is cost of quality. Cost of quality can be broken down into 2 major categories. First is the cost of conformance, or the money spent during the project to avoid failures. This can further be subdivided into prevention costs, which is the cost to prevent errors, like training the team, creating documents, on equipment, and in time to do it right. The other subdivision is appraisal costs, or the cost for assessing quality, like testing, destructive testing loss, and inspections. The second category is the cost of nonconformance. It is the money spent during and after the project because of failures. This is subdivided into internal failure costs. It is the cost of failures that occur before the product is released to customers, for example, rework and scrap. The second subdivision is external failure costs. It is cost incurred on failures that occur after it has been released by the team, for example, liabilities, warranty work, and lost business. Concept-based questions on cost of quality can be expected in the exam, so please make a note of the categories of cost of quality. Let us look at the project quality management processes in the next screen. There are 3 project quality management processes, of which the first process, Plan Quality Management, is done as part of the Planning Process Group. The next process, Perform Quality Assurance, is done as part of the Executing Process Group, And the last process, control quality, is done as part of the monitoring and controlling process group. In the next 3 screens, let us look into each of these processes in detail. The aim of the plan quality management process is to identify the relevant requirements or standards to execute the project effectively to achieve the desired quality level. Quality planning results in the creation of the quality management plan. Aim of the plan quality process is to identify the standards. A standard is an agreed-upon process to work or achieve a result. A standard can be set from within the organization or government. Once all the standards for the project are identified, the aim of the quality planning activities involves determining what work needs to be done to meet those standards. Before adhering to the standards, you should question their relevance with the project. Implementing all possible standards applicable to the project in random will have cost and time implications. Let us look at the inputs to this process. The project management plan provides the scope, schedule, and cost baseline, all of which have an implication on the quality management plan. Quality plan has a direct correlation with these. It might also have an impact on and be impacted by other subsidiary management plans, such as risk management. The stakeholders of the project may have specific requirements and views about the quality parameters of the project, and these have to be considered. The risk register gives an indication about the kind of risks that are inherent in the project, and also those which must be considered while planning the activities to ensure quality. The requirements for the project need to be considered for planning quality-related activities, because quality is all about meeting the requirements. In addition to these, enterprise environmental factors and organization process assets are also listed as inputs, because the standards can be either from within the organization or from government or other external bodies. Standards from within the organizations are usually the best practices learned over a period while executing numerous projects. An example of government standards can be standards to control air pollution by the motor vehicles, which vehicle manufacturers must adhere to. To accomplish quality planning, first, analyze the benefits versus the costs of meeting quality requirements. Next, identify the cost of quality and confirm if that kind of investment in quality is justified. In addition to these two, benchmarking helps in analyzing the quality of activities of similar projects executed in the past. This helps in identifying the particular quality of output of the previous project, which in turn acts as a basis for the current project's quality planning. Design of experiments can also be used for quality planning. This is a statistical way to determine what variables will improve quality the most. For example, in case of manufacturing doors, it can be determined that increasing the quality of the wood can have maximum impact on improving the quality of the door. In addition, the 7 basic quality tools, also known as the 7 QC tools, are used to determine the plan to achieve the desired level of quality. Statistical sampling as a tool becomes relevant whenever the quality plan cannot be applied to all the artifacts produced. For example, if destructive testing is a requirement, then it can be carried out only on a sample, not on the entire population. Statistical sampling helps in arriving at a representative sample that can give useful information. Other additional tools, such as brainstorming, force field analysis, etc., may be used to determine the quality management plan for the project. Conducting regular meetings is another important tool. The quality management plan has to be determined in a collaborative manner by consulting the team members and other stakeholders. Quality management plan is a key output of this process. Checklist is a list of items to inspect. For example, many of the office buildings have housekeeping checklists to ensure that all floors, cabins, etc. are cleaned. Checklists are created during quality planning and used in quality control. Metrics are project-specific data that need to be measured to check the status of the project. The simplest project metrics can be cost and schedule. Metrics are also decided during quality planning and used in quality control. One of the roles of the project manager is to not only manage the project, but also improve processes in the project to decrease the instances of defects, which in turn saves time and money. Such activities are listed in the Process Improvement Plan, which eventually becomes part of Project Management Plan. As a result of the planning activities, other project documents may also get updated. For example, the Quality Management Plan may result in updates to the cost or resource requirements. There may be questions in the PMP exam based on the Plan Quality Management process, so please ensure you have a fair understanding of the concept before you take the exam. In the next screen, let us discuss the second quality management process. Once the quality planning is over, the next process in project quality management is quality assurance, which involves determining whether the standards are being met and the processes are being followed. Therefore, the input for this process is the work that has been completed during the quality planning stage. They are project documents, quality management plan, process improvement plan, quality metrics, and quality control measurements. Let us look at the tools and techniques used in this process. Quality audit is the process to check whether the project is complying with the organization policies, standards, and procedures, and determine whether these policies, standards, and procedures used are efficient and effective. So a good audit not only looks at this compliance, but also for the new lessons learned from the current project that can help make the future projects better. Process analysis involves using the lessons learned from doing the initial few work to make the remaining work more efficient. For example, if the project involves installing a software package, then the lesson learned from the first few installations can be used to improve the process on remaining installations. Apart from these, all the quality management and control tools, such as the 7 basic quality tools, will be relevant to this process. The key output of this process is project documents updates to ensure that if there is any deviation from agreed standards, it is corrected. Also, if there are any lessons learned that can help improve the future projects, the organization process assets get updated. This quality assurance may result in improvement suggestions, change requests may be generated, and the project management plan may need to be updated. Understanding characteristics of quality assurance tools and techniques may be useful while answering the exam, so prepare this topic well before you take the exam. In the next screen, let us discuss the last process of quality management. The key focus of the quality control activities is on the correctness of the work. Quality control helps answer questions like, is everything okay with the project? Does the project plan require changes to successfully execute the project? Will the project succeed, etc.? Let us look at the inputs to this process. The quality metrics measurements are done continuously to see whether the project quality is improving. The project deliverables are inspected against the planned checklists. Quality control acts upon the deliverables and work performance data produced in execution. It also refers to the project management plan for understanding deviations from the plan. It also considers the approved change requests, information from other project documents, and organizational process assets. There are 7 popular tools and techniques used in doing the quality control activities. They are collectively known as 7 basic tools of quality. Other relevant tools are statistical sampling, inspection or testing, and review of the approved changes. Quality control activities result in quality control measurements, the verified deliverables, validated changes, information about the work being performed, recommended changes, and updates to the organizational process assets, project management plan, and other project documents. In the next screen, let us look into a business scenario to understand this concept better. After reading the problem statement, click the Solution button to look at a possible answer. Six Sigma is a highly disciplined process that focuses on developing and delivering near-perfect products and services consistently. If a large volume of data is plotted over a period of time, you would most probably have a bell-shaped graph. Such graphs are also called normal distribution graph. It's called as normal distribution because any large volume of data is plotted with the intent to track variations would most probably be in a bell-shaped curve. The line corresponding to the top of the bell curve is the median of the data sample. Standard deviation concept is used to measure how far any data is from the mean. Standard deviation is also called sigma. One standard deviation from the mean covers 68% of the data. 6 sigma means 6 standard deviations from the mean. This would cover 99.99966% of the data. We will look at an example of 6 sigma in the following screen. To understand 6 sigma, let us look at an example. A tire manufacturing company produces 100,000 tires a day. It is not possible to verify each and every tire manually to ensure it is defect-free. Instead, random sample of these manufactured tires are taken and checked for defects. Assuming that the thickness of the tires is a parameter to measure defect, any tire that has a thickness more than or less than 10 millimeters is considered to be defective. Now, if you measure the actual thickness of all 100,000 tires manufactured daily and plot them on a graph, you get normal distribution graph. One standard deviation from the mean covers 68% of the data, meaning if the thickness of the 100,000 tires are plotted, 68,000 of them lie within one standard deviation above or below the mean. Now, if a company operates at 6 sigma level, they would ensure that all tires that are up to 6 standard deviations from the mean are defect-free. Therefore, in such cases, you can expect only 3 defective tires out of 1,000,000 tires manufactured. Let us now check your understanding of the topics covered in this lesson. Here is a quick recap of what was covered in this lesson. A project is said to meet quality expectations when all the project requirements agreed in the beginning of the project are met and the resulting product is usable. Quality management includes creating and following policies and procedures that meet the project's defined quality needs. Quality planning defines the standards, templates, policies, and procedures. Quality assurance determines if the project is complying with the policies and procedures. Quality control measures specific project results against standards. Plan quality management, perform quality assurance, and control quality are the 3 project quality management processes. 7 basic quality tools are used to plan and achieve the desired levels of quality. At 6 sigma level, there would be only 3 defects out of 1,000,000 units manufactured. With this, we come to the end of this lesson. In the next lesson, we will cover Project Human Resource Management.